All right. We are at the top of the hour. We're going to start. Welcome, everyone, to another amazing Modev platform presentation. Excuse me. I'm Jyoti Gulani, your host for today. I am founder and managing director of AI. We're a consultancy. We do AI-enabled generative capabilities for strategic enterprise clients. And we are here today to actually discuss something very interesting and my favorite topic, which is empathy and AI. And in particular, the team that's joining us today, audEERING, is going to be walking us through how machines are learning to understand humans, and in particular, from a voice perspective. So very excited to bring Florian Eyben, who is the co-founder and CTO of audEERING, and Soroosh Mashal, excuse me, is principal AI strategist. We're very excited to dive in, and I'm going to first start with introduction. But before we do that, just a few housekeeping things. Please feel free to share in chat any comments or discussions, Q&A. We will be pausing at specific points to ask a question. I'll be keeping an eye on that. But we've got exciting material up ahead. So if there's something that's going to come up ahead, I'll tell you just gotta wait. And then we'll do some Q&A at the end as time permits. So with that, Soroosh, the floor is yours.
Thank you. My name is Soroosh Mashal. As Jyoti said, I'm the principal AI strategist at audEERING. I have been in the IT field for 1.5 decades and almost 1 decade focused on AI. I've been always fascinated with artificial intelligence, and in the past years really focused on voice to understand the expressions of human beings. And that's what we're going to and show you today. So with that, I'm passing on to Florian. Flo?
Hi, everyone. I'm Florian. I'm CTO and co-founder of audEERING, and I have a background in electrical engineering from Technical University of Munich. And I discovered my passion for audio, music, and speech analysis there. Continued to do a PhD in the area of speech emotion recognition, working on a very interesting project to create a sensitive artificial listener, so a chatbot capable of doing mostly nonverbal communications and reading between the lines instead of looking at the text. And then in 2013, I co-founded audEERING, and that's where we are today. I'm not going to spoil too much of the presentation, so I'm going to hand back to Soroosh, who will start and give you an introduction over today's topic.
Great. Awesome. Thank you, Florian. All right. Without further ado, let's get started. Our presentation is called Empathy is the Key. And we want to see if the voice-based AI is the next big thing. Let's go. I'm going to kickstart by an episode from The Big Bang Theory. I'm not sure if you have watched it. If you're a nerd, you have probably done that. So without further ado, let's go.
Hey, Leonard, if you're happy and you know it, no need to clap your hands because I have an emotion detector.
How's it working out?
Did surprisingly well.
Oh, that's great. I'm happy for you.
Hold on. Oh, well, you are, aren't you sweet?
What's that? Are you working on your resume?
No, it's my brother's. I'm trying to help him get a job out here.
Ooh, and that makes Leonard angry.
No, it doesn't.
But Leonard, please. I know an angry face when I see it. It's this red frowny guy on my phone.
Are you really upset about Randall coming?
No.
Yes.
I said no.
Dude, he's like your twins.
Leonard, if you're mad about this, just tell me.
Fine. You invited your drug dealer brother to stay with us for God knows how long and didn't bother to ask me first.
He's my brother. I didn't think I needed your permission.
Well, hey, now she's angry too. Whoa. This thing works like gangbusters did.
All right. This episode came in 2027, and they were already working on this technology at that moment, by the way. And for me, while seeing this episode, I was just like, one day we're going to reach that level of accuracy that we can build a sarcasm detector for Sheldon. And yeah, that's then we really put all the efforts into this technology. Although the audEERING is over a decade old, I think 2016 and so on was the time that we just like really kicked it off. But yeah, so that's how it started. Bear that in mind, this video clip and this futuristic vision. You definitely don't need that big emotion detector to carry around. We all have microphones and we all have our phones, and that's enough considering that AI is so powerful nowadays. Let's come forward to today and the latest release of ChatGPT 4.0 on June 5th. Let's play a game. Let's play a game to see if ChatGPT can detect the emotions in our voice.
Hey, let's play a game. I say a sentence and I want you to complete my sentence.
Sure, that sounds fun. Go ahead with your sentence.
The landscape is
breathtaking with rolling hills and vibrant wildflowers.
The landscape is
filled with tall, whispering trees and a gentle, winding river.
The landscape is
painted with the golden hues of a setting sun, casting long shadows across the fields.
All right, as you can see here, no matter what emotion I was expressing, ChatGPT's response was always casual, like it was oblivious to my state and the context of the conversation. And that's the state that the tech giants are offering and people are using. And this was not the world we wanted to see, because we do not like, if you look at our interactions as humans, it doesn't matter what you say. It matters how you say it. And that is the important point. So that inspired us to create a better version, which we called ERA, an emotionally responsive assistant. So let's have the same conversation with ERA.
I'm here.
let's play a game. I say a sentence and I want you to complete my sentence.
Sure thing. Go ahead and start your sentence.
This landscape is...
This landscape is eerily quiet and a bit gloomy.
This landscape is...
This landscape is quite serene and calming.
This landscape is...
This landscape is truly breathtaking and inspiring.
This landscape is...
This landscape is slightly dull and uninteresting.
Thank you.
Probably have seen the difference here, as it denoted by the color and the values that you would soon understand what they mean. The emotion in my voice is detected in every segment, and the large language model is reacting to that emotion and adjusting the response. Clearly, I just used this game to obviously show you what it means, but actually in our day-to-day conversation, as we speak to each other, it's all those subtle changes, and detecting emotion and not detecting emotion turns someone into Sheldon and someone into Amy, let's say. All right, let's go. So let's take one step back and go through the history of voice AI and where we started and where we are right now. So let's start by 70s. In 70s, you had limited systems that could just detect some vocabulary and simple commands, like you would say hi, and exactly the word hi was detected, and you know, something would move. Let's say a robot could just like raise a hand or something like that. No emotion at all, not even understanding the words completely, like a really simple pattern recognition on some, let's say, voice commands and so on. Then you have 80s, which you have like more sophisticated speech recognition systems, but still there's like no emotion detection whatsoever. And then you come forward to 90s, and people like could understand, and that's the time that we had the breakthroughs. So we had pitch detection, tone detection, rhythm, and we understood that, wow, these are the points, that these are the features that are contributing to the changes in the emotions. By the way, nowadays we have a lot of companies that are just selling this pitch detection as the emotion detection. So when you're out there shopping, just be careful. And then we just come to the new millennium, and we have machine learning and AI. So we have assistants like by the end of the decade, almost like Siri, Google Assistant, and we have speech recognition systems. It means that computers now can detect what you are saying, and they can do it relatively good, at least in some common languages. Not most of, like, it's just English, let's say some larger languages. And then in 2010s, we have the deep learning method. So we have more computing power, which means we can create better models. We have convolutional neural networks, recurrent neural networks. We can model the complex emotional patterns. And this was the moment of breakthrough. And that was, by the way, when we started the company. And we use all of those models to detect them. It was super fast. It was still accurate, but not, in some cases it was accurate enough, but in some other cases it wasn't still accurate enough. And then at the start of this decade, right after pandemic, we had transformers. GPT, transformers. And using the transformers, we could reach the human level accuracy. And right now, as I'm speaking to you, and as you just saw it, we have real-time emotion detection that can be applied to different industries and different use cases, which we are going to cover by the end of this slide deck. So the question is, as I told you, in our daily interactions, we are constantly expressing ourselves. And I really want to take a moment to differentiate between feelings, emotions, and expressions, because people usually mix all of these. So feeling is some phenomena that is like completely subjective and happening inside. For example, you can be like, I feel I know that person, but that is something that is inside of you, it's happening. And then that emotion can be a confusion, for example. So you're not sure if you know the person or not, or it can be excitement because you're like, I feel I know that person. So this is the emotion that is the result of that feeling. And then you have expression. So then you can choose as a person to express that using your voice. You can be like, oh my God, Jamie, you're here. That would be the expression of that emotion. On an everyday basis, we just use these words interchangeably, but scientifically speaking, there is the difference. So you have feelings fully private, not going to touch them. You have emotions that are the results of that, and then you have expressions. And expressions are what we are focusing on. And that's a form of communication that connects humans together. So that's the heartbeat of every interaction. Because these expressions fuel our interactions and, makes us humans. All interactions can be natural if you have these expressions of emotions in there. If you take that expression out of every interaction, all of a sudden you would just remain with some machine-like and like void interaction that is not authentic and it is not meaningful. And sadly, that's the world that most of our interactions today are just like that. So if you look at the history of humankind, we have always been interacting with our pets or animals, other humans, with entities that could understand that emotion and could respond properly. then we have this period of couple of decades in the whole history of humankind that we lived in, that we just interacted with machines that cannot understand emotions and they cannot respond properly. And hopefully with the help of AI, you're going to have machines that can do that, and it's going to be like that for the rest of our humanity. So it means that using the AI, we can connect human and technology together and bridge that gap between the human and the machine in general, and unlock that human-machine interaction or human-computer interaction. So yeah, using that, we are going to live in a future that most AI agents can express feelings, can express that emotion, and they wouldn't be limited anymore. And they would have the ability to understand the user's mood. And yeah, we will reach a level that every interaction is humane. So yeah, I'm going to pause for now, and let's see if there is any questions so far.
All right, we haven't had any questions come in, but I actually want to point out something really critical that you are extracting here, right? You talk about a lot of this is about humans, so more anthropology. I'm sure you guys have studied, humans in detail, and the fact that we feel something and gives rise to an emotion that's all inside. We talk about the inside voice, for example, but the expression is really what you're leveraging to see how we are feeling and what emotions we have, right? I mean, it's such a fascinating topic to say, could machines understand us better than humans can understand each other? Sometimes we have issues understanding each other, right, based on expression. And in particular, you're looking at the sound produced, the voice, right? Because
exactly
expressions, etc. But you guys are really, really focused on the voice part, which I think has tremendous potential relative use cases, which I know you're going to cover. But thank you. If you want to continue, Soroosh, back to you.
Sure, great. I would like to pass it on to Florian as we are digging deeper into the technical slides. So Florian, would you mind?
Absolutely. So I'm very happy to give you a bit more insights into the technology and how we build empathic conversational AI. So you might be very well familiar with traditional conversational AI, where you have a speech-to-text component, you pass it on to an LLM or some dialogue engine, and then you would synthesize the text back to speech to get a voice response. Basically, we use the same path here. So what we provide can also plug in with existing systems that you might have. And we add to the text the expression detected with our device technology. And then we, of course, fine-tune the LLM in a specific way, add some specific prompting so that you can get a very empathic and natural dialogue. I'm going to just on the next slide show you an example how this could work for music selection.
Hello, Diana. Can you recommend some music to me?
Sure, based on your tone, I think you might enjoy some uplifting pop music. How about listening to some songs by Taylor Swift or Ed Sheeran?
What about some music like this?
Sounds like you're in the mood for something more intense. I'd recommend some rock music, perhaps something by AC/DC or Linkin Park.
Oh, great. And what about some music like this?
Based on your tone, it seems you're in the mood for something more laid back. How about some jazz or blues? Artists like Norah Jones or John Mayer might be just what you need.
Okay.
I see you're not quite convinced. Let's try something else. Considering your mood, how about some classical music? Beethoven or Mozart could be relaxing.
So as you saw, based on the tone in my voice, the music recommendation was adapted. And also, as to the last recommendation of Norah Jones or John Mayer, I was just answering kind of like a disinterested okay. And it picked that up and said, hey, you're not convinced. Let's try a different suggestion instantaneously without just saying, I said okay, so let's continue with that suggestion. All right, then let's look what we have under the hood, because obviously understanding the technology that's there, being able to explain it, helps you build trust. So that's why we offer some transparency and a bit of insights. Of course, everything is based on AI, deep learning, unsupervised learning, so the latest trends that we have. But audEERING combines this with around 7,000 interpretable voice features that we can measure. That's the asset that we started building up when we built the company, extracting and interpreting features. We've also applied this in the healthcare space for vocal biomarkers. And we combine this with deep AI methods so that we can accurately monitor what is happening and that we can actually build robust systems that we know what they're doing. Of course, also an ingredient is that we have millions of hours of training data to build our AI on. And we focus on not having large models that only run on GPUs in the cloud, but also having models that run on the edge on devices like a smartphone or even smaller devices like headphones. And that's really a unique point where we are the experts in this area. Now, you might have wondered, I mean, you heard a lot about expression. Soroosh was talking about that this is essential for the interaction, for fully understanding what we're saying. How do we represent that? I mean, for text that we detect or that the system detects, it's easy. We transcribe it with words. But how do we represent expressions? Can we say somebody is angry or happy? But there are many, many terms that would express emotions or emotional expressions. So we've adopted a dimensional model from psychology that is very common in the area, and it's called the arousal, valence, and dominance model. And the performance that we can measure here is not given as accuracy, but it's given in terms of concordance correlation coefficient. So our reference is the human being. So a human listening to speech and perceiving those dimensions. The human being was trained based on literature from psychology and everything to rate these samples. And on the next slide, we will see kind of an example of the arousal valence space. So arousal, for those of you who are not familiar with it, is kind of the energy or intensity that you put in your expression, whereas valence is whether an expression is positive or negative. And in this kind of arousal valence space, for example, you can place expressions like annoyed or delighted expressions versus relaxed and bored expressions. Now we have a few samples in here, and I think, Soroosh, you best walk everybody through as you're playing back the samples. That makes sense.
Sure. So here I'm just going to go over the samples here. I start by the middle point, which is a fully neutral. Here you can hear the exact same sentence being said in different tones. So let's start. The pen is on the table. The pen is on the table. Intentionally, we use words that are not emotion-laden. So pen, table, these are all completely neutral words. Now let's listen to the other one. The pen is on the table. This was not particularly positive or negative, but simply louder, and that was like, that had more arousal. The counterpart would be this one. The pen is on the table. So you could just hear this like relaxation in there. Now on the other side, we have it as almost the same level of arousal as the neutral, but really positive. The pen is on the table. And then ultimately you would have the full level of valence and full arousal, which would be super excited about something. It's on the table. Right. On the other hand, if we go to the negative valence side, we would have on the same line, the pen is on the table. You could hear this like, yeah, the negativity in my voice. And then but this was really low in arousal. And then if you would have really high arousal and low negativity, that would be furious.
The penny's on the table. Sorry, I should have said to, yeah, be careful with that. Yeah, and then we also have the depressed, which is like sobbing and crying. So really negative, but really low in arousal. And then we have really low in arousal, but like also positive, which is like this relaxed, chill state. It's on the table. Right. So this was about like the arousal and valence. Now the other one would be the dominance. That would be too complicated to bring it into two dimensionals. And that's why I'll just have two examples of really high dominance and low dominance, which you can hear. So here is like the low dominance. The pen is on the table. Right. This was, you see, it was still loud, but the dominance was really low. And that was kind of like more like a panicked state. And this one, be careful. The pen is on the table. This was really high dominance. So, Florian, back to you.
Perfect. Thank you, Soroosh. Now, these numbers here in the table that you see are just a bit of insights into how good does this work. We always ask the question about accuracy, and also being asked about how does it work in different cultures, different expressions. To the first part of accuracy, our reference, as I said, is the human. We take experts that we train on this, but we also have to take multiple experts because this expression annotation is not something that is precise. You do not have one ground truth, but you need to ask a few experts and see where they find a consensus or an average. And that's in essence what we do. And we compare then the outputs of our AI to naive average human assessors. And we find that the AI is at least on par or even a little bit above, because it was trained by experts, as the human assessors. And that's really an important part. And then, of course, second part is cultural diversity. Expressions will differ. But as we're looking at only these primitives of arousal, valence, dominance, we have another layer of interpreting them. So where to put the excited or the depressed part. And the arousal in particular, there's a lot of literature on it, and we did some studies on cross-cultural perception. That seems to be quite universal, except for some kind of offset, which can be between different cultures and which can be within one human being also. For valence, it's of course more culturally specific, and we tackle that by training our AI on data from many, many speakers from many backgrounds and cultures, so that it all learns these aspects implicitly. All right, then let's go to the next slide. Here will be a quick demo of how the raw expression detection will work. And just play the video because there's an explanation in there.
I will now show you our audio-based emotion recognition technology. Down here, you can see the voice activity box. Whenever I speak, you see that voice activity is being detected and speech segments are being displayed. If I just clap, then no activity is being shown. Now I will demonstrate the emotional expression recognition, which is based only on tone of voice and acoustics. Therefore, I will say the same sentence in different emotional expressions. The quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog.
Okay, so you could see also the latency. So it's almost real time. So after I finish speaking the sentence, it will immediately update within a second or so. And you could actually get the concept that it's not what I'm saying, but it's how I'm saying. So we can separate those two and use it also to detect things like irony or sarcasm and so forth. Okay, here's another demo of how this would work when we chat with it voice to voice. On the left side, we see normal ChatGPT without any expression information. On the right side, we see the information or the chat, how it would work if we had our expression detection. Let's go.
Hi, Diana. How was your day?
Hey, Florian. My day was pretty average. Nothing too exciting happened. But it was nice and relaxing overall. How about yours? Anything interesting or eventful?
Yeah, a lot of interesting stuff.
Oh, I'm sorry to hear that your day didn't go as well as you had hoped. Would you like to talk about what happened? Or is there anything I can do to help? Sometimes it can be helpful to share and vent about things that didn't go as planned.
I really got you there.
Haha, you got me indeed. I'm glad to see that you're feeling quite positive and content. It's always nice to have days that bring you joy and excitement. So what happened that made your day so great? I'm all ears.
Well, I'm so honored to talk to you, Diana, and it's so great to see how Empathic AI can come to life.
Thank you for your kind words, Florian. I'm here to listen and provide support whenever you need it. It's wonderful to be able to connect with you and create an empathetic experience. If there's anything specific you'd like to talk about or any topic you'd like to explore, feel free to let me know.
Sure. Let's play a game. I will say a sentence, and you will tell me how my emotional expression on that sentence is.
Sure, let's play. I'll do my best to interpret your emotional expression based on the sentence you provide. Fire away.
The quick brown fox jumps over the lazy dog.
Based on the sentence, the quick brown fox jumps over the lazy dog, your emotional expression seems to be slightly negative and low in arousal. Perhaps you're feeling a bit bored or uninterested at the moment. Is there anything specific that's contributing to this sentiment, or is it more of a general feeling?
Let's play again.
Of course, let's play again. I'll do my best to guess your emotional expression based on your sentence. Feel free to give it a go.
The quick brown fox jumps over the lazy dog.
Nice! Based on the sentence, fox jumps over the lazy dog, it seems like you're feeling quite positive and content. The lack of arousal suggests a calm and relaxed state. It's great to see that you're enjoying the game and feeling good.
All right. Then you could really see here that you can have a bit more natural conversation. It also picks up things like being a bit sarcastic or having a mismatch in your tone and text. And that really shows us this potential of how important our expression is and how much more of a natural conversation we can have if we add that component. Now I hand back to Soroosh, but before we get there, or no, let's do this one, then we can have a quick Q&A.
Great. All right. So yeah, back here. Here I'm just going to show you how this works for the ones. I mean, everything we showed so far are demos that are available, so everybody who wants to use the demos can use them. But I know there are a lot of geeks out there who just want to have the command line interface and just get their hands dirty in the terminal. So for those of you out there, that's how it works. So here I just bring up the Audacity. I just record a short segment and to just show you like how it works. We can just save that segment. Let's call it test.wav. And then I just open the terminal. I call on the devices to CLI. I pass the resource files, which are like, all the models that I need to use. And then I just pass the serial key that I received after, getting the package. And I just call on the models that I want to use, which are voice activity detection in this case and emotion large. And here I just call on the test file that I just recorded. And here you can see this was around 3 seconds, and you would receive the categorical results and the dimensional results. And as you could see, the dimensions and categories are correlated with each other. So here we have high arousal, high valence, which means a happy or excited state. And as you can see, it's like 99% happy. That's a chance of existing any happiness in the voice segment, which was, well, correct. Yeah, that's it. So, all right. No questions?
Yeah, there's actually a few.
All right.
So Melanie asks, what's the difference between voice analytics and voice biomarkers, which is used in your technology?
Well, yeah, Florian, go ahead.
I'll take that one. So the difference, voice analytics is more general. So voice analytics is basically analyzing everything of your voice with AI or with some features. And vocal biomarkers is a specific term that refers to the healthcare space. So if we find some markers like your articulation would be decreased or unclear, or if, for example, your speaking rate decreases, and that would be related to a certain disease, just like your blood pressure or any other marker of your body changing. That's the definition of kind of where vocal biomarkers is being used. There's also acoustic features, so like pitch of your voice, loudness, or even speaking rate of these things. And audEERING uses both. So we combine the acoustic features with AI and deep learning. And AI basically is you give a sample of audio, you give a label, and let the machine learn it. And I think that would be more close to what you meant with voice analytics. But if anything is missing in the explanation, right in the chat, we can take it there at the end.
Great, thanks, Florian. Just a few more. So Maggie Smith's talking about, leveraging expression. So do you find expressions differ in different languages and different cultures? For instance, some expression would sound like yelling or anger to another culture. For example, the way Greeks are, or even Indians, the way we speak, right? Everybody's very, very different. And she's just trying to understand inclusivity with AI empathy coding. I think you touched upon that, right? Cultural significance and context. Can you expand on that a little bit?
Absolutely. I mean, this is very important to have inclusivity, or at least to know for which cultures and dialects the engine works. We've set up a very extensive fairness and robustness testing suite here so that we can trace the issues and actually improve the technology based on that. That has already, in the last few years, led to significant increases here on the fairness part. So fairness regarding gender, fairness regarding languages, fairness regarding accents. However, of course, that it's very diverse in the whole world. So there's still some way to go to include everybody here. But what we specifically aim at is, as I said before, kind of the primitives like arousal, valence, dominance, to detect them in a more universal way and offer some calibration. So, for example, the Greek or Italian might generally have, on average, a higher level of arousal than the German or the Danish, north-south axis maybe in Europe. And that way we can assign kind of, if we want to interpret the value, so if we want to say, what is a high level of arousal? What is excitement? We can apply different thresholds here, and we can apply different interpretations. And last thing, of course, next to the fairness and robustness tests that we're having, we're of course very concerned with getting a very diverse pool of data, and that's where we have spent a lot of engineering on it, and a lot of scientists in our data team have worked on this to collect a very representative pool.
So as you've shown, it's not a one and done like ChatGPT is like a one size fits all. You're really providing those levers for applicabilities to a specific use case, right? You're being very sensitive to the fact that it is inclusive. And I think it matters, right? So I love the fact you do that. Jacob's actually asking, would this be released as open source? He's a computer science college student. He wants to be able to support his projects for hackathons and personal projects. He actually won second place at his college's engineering hackathon. Congratulations, Jacob. This is actually just last week, but he couldn't use audEERING's open smile with hugging face pre-trained models. So they ended up using CV deep face. So anything on the open source side?
Sure. I mean, we offer quite a few open source components. So if you check out our GitHub page for audEERING, and also we have a model or two on hugging face that we offer as open source. But you can also, for your projects, go to our website. We have easy to access web API. Recently released some prepaid packages. You top up some credits. And you can use the best-in-class models and accuracy here. But you can also check out the open source parts. They're free for non-commercial use. So for personal projects or university use, they're perfect. Cite us if you use them. And if you need something more easy to use just by a REST API call, feel free to check out the prepaid packages or directly contact us for collaboration opportunities or for purchasing other packages.
Great. Susan's asking, where would sarcasm be placed on that chart that you had shown previously? If you want to back up into that.
Absolutely. So sarcasm is not on the arousal valence dominance plane because sarcasm is a more high-level construct. It depends on the context, on your conversation and the content. And we would see it more to be placed on something not matching expectations. So your tone not matching the text or not matching the tone as it would be expected in the flow of the conversation. And that would then be interpreted, for example, as sarcasm. However, there's a lot of research on sarcasm separately, so it's probably not as easy as just putting it like that, but I think that should suffice as an answer for now for everybody.
Yeah, actually, Greta brought up a good point. Combination with the use of avatars. If you use, you're doing the voice part, combining it with other expressive emotions or other areas. Do you guys see a lot of that being used in the use cases and the clients you're working with?
Soroosh, I think you're best to answer this one on avatars.
Yeah, so on avatars, there is already used a lot in the metaverse area. Those are the ones that we're going to touch on in the use case section. So I'm just going to keep something there. But in addition to that, the expressions can be used to change your avatar, because when we go into a metaverse, it's all about expressing ourselves and doing stuff that we cannot do in the real world, right? And you have a full spectrum of the avatars. Like you go from fully photorealistic for certain use cases to fully expressive, like in fantasy cases. And there's an article that you can check on our website called Effective Avatars. And in that, you can read about all the different studies that have been done and proven how valuable this is. So
excellent. I'm going to ask a question, and then I'll have back to you guys to continue with these use cases. So Melanie's asking about how can you eliminate false positive reaction through vocal expression for specific use cases. For example, in a therapy application, if a patient has learned to have a happy expression, can your technology hear past that? I guess people sort of saying things that they don't actually feel, right, between emotion and expression. That must be difficult to do, right? Because you're depending on the expression and not really what's on the inside, right?
Exactly. So if somebody is a real good actor, like Soroosh, and he can just portray a happy voice at any time, then the technology cannot hear past it. However, nobody's perfect. And let's say a therapy application, we're not looking at a single segment of expression. We're looking at a whole interaction, the whole session, or even over time interactions of this person with other people. And we see a range. We see a progression of the person. So if they try to speak happy all the time, or have learned that, there are some segments that fall below happy. So if we look at the whole picture, we probably are very likely to see if they're making progress on their therapy, if they're trying to mimic happy, but then cannot sustain it. Because obviously, if you are, for example, suffering from a depressive episode or some depression, then you simply might lack the energy to express happy to the fullest. And that is then something that affects your expression and that we indeed can detect. And we have found this a couple of times when we try out our technology or do some demos in the evening and we're tired. For some reason, we cannot reach the very high level of expression and we think something must be wrong with the code. But in the end, we find, well, we recorded our voice, listened to it the next day, tried it again, everything worked, listened to the recording, said, yeah, it wasn't that energetic. So it's often also an issue that we're having a hard time perceiving ourselves right on those details. And yeah, that's the answer to the question, I think.
Yep, absolutely. And thank you for pointing out that this is about making progress, not perfection, right? There's no way any technology can ever recreate what Mother Nature has taught human beings, right, for millions of years. So back to you guys. Continue the presentation. Thank you.
Great. Thank you. All right. So yeah, back to the use cases. So right now you understood the vision, you know the history of the technology, you know how the technology works, and let's look at the industry and see where this technology has been applied so far and is more likely to be applied in the future. I'm in the interest of time, I'm just gonna go a little faster. Just gonna start by call centers. So call centers, you know, you call, you're angry about something, they want to help you, you don't get it right, you know how it works. And pretty much there is a lot of potential there to just detect the expressions of the caller, detect the expressions of the agent, so that when agent is working, they can see how they can turn like a quest, like a game, every angry customer into a happy, satisfied customer, and let's say get some coins for it. This is all about the just. I urge everybody to think of it as more like a game for the agent to make their lives easier, rather than like something to control and so on. And that's how the Jabra Engage AI works, which we are going to delve deeper into that. Then the next use case would be the IoT and smart devices. So it's all about having the scene analysis, voice analysis, and ensuring that you can adapt to different situations based on the acoustic scene, for example. Just imagine, for example, again, for Jabra, you had headphones that have noise cancellation, but the noise cancellation depends on the environment. So for example, if you are in a, like, let's say, using public transport, that's a different noise, requires different algorithm than, let's say, you know, being in the traffic. And this is one example of like really low resource models that can be integrated in devices. Then we move on to the automotive, robotics, and in general, voice UIs. This is a really, really huge area, and we are seeing a lot of rise in this field. And it is just all about like enabling robots, humanoid robots, or let's say any other robot that is interacting with humans, and cars to create this natural empathic interactions via voice. So, like examples of that are Hanson Robotics. You probably know the robot Sophia. You have seen it a lot. And Mercedes, BMW, and so on. They are all the ones that are working on this, and we have worked with them, of course. Moving on, we have market research. So this is a really huge industry. And what you want to do in market research, you want to ensure that you, but while doing the analysis, you really get how people are expressing their idea about a certain product in, let's say, your A/B testing and so on. And here, this measuring the experience and interest in the voice matters a lot. Otherwise, there's a lot of manual job that has to be done in there, like to do that. And using voice AI in market research allows you to see more and save time, in a nutshell. Examples of that are iMotion, GfK, Ipsos, and L'Oreal that we can delve deeper later. Moving on, my favorite is XR and edutainment. So as you could see, like with the rise of metaverse and so on, we saw this VR experiences that are used for education, serious games, training you before you actually go and face a dangerous situation, whether this is like a phobia or training for a specific use case, whatever that can be, like in hospitals, in high stress situations. One way is to reenact and do that like with actors, which cost a lot. And the other way is to just do it as a serious game that everybody can play, which is way better. People feel a lot better in that. But the issue with that is that to do that properly, you need technology that can detect your expressions and ensure that provides you with the correct feedback. And for that, we have worked with Salesforce, Simulation Crew, Straight Labs, and Liminal for different use cases, ranging from training people to do public speaking, to be confident, because so many people in the world, like about over 70% actually, have stage fright, which means that no matter how ready they are, when they want to start presenting, they always have the butterflies. And to fight that, you just have to practice, and you have to practice immersed in the same situation and get proper feedback. And well, that happens through XR with the help of course, Expression AI. Last but not least, we have the healthcare and well-being, and this is all about those voice biomarkers that Florian mentioned earlier. And this is about like monitoring the neurodegenerative diseases, mental diseases, and having enhanced therapy. Alrighty. So speaking of that, one of the use cases was Simulation Crew. They created a product called Patient Comfort Technique, which helps people to, for mostly like interns, to get and face those stressful situations before they actually go to the hospital. Because, for example, like imagine you want to train an intern to react properly to somebody who's like coming and storming in. I'm like, I want to talk to the doctor right now. And how would you do that? Like, how would you actually train that person? You have to either hire actors or you have to simulate that. And then how would you do proper interactions? Clearly, you need an AI that detects the person's expression, and the person can go through it multiple times. And this helps the team to add a new layer of expressive interaction to the scenarios in VR. We had iMotions, one of the best use cases in market research. So audEERING is already fully integrated in iMotion, and you can see how it works. Like you can create analysis and just have different tests and get proper results. As I mentioned, the other case is our partnership with Hanson Robotics, creators of Sophia. And this is all about adding this social competence and being able to detect empathy, of course, and having this natural interaction. Right. And then we have Jabra Engage AI. At this point, I would like to pass it on to Florian to continue. Flo?
Perfect. Thank you, Soroosh. So Jabra Engage AI is a product for the call center. And you might know Jabra from headsets and speakers. And recently, with our help, they're bringing to the market a product, purely software product, that does tone-based analysis of your speech for the contact center. And in customer service, it's very important that you are friendly, that you sound polite. And that is what we provide with this tool to the agents in the contact center, kind of as a mirror for their voice. You can have a mirror for your face and see if you're smiling, but for your voice, you only hear it through your bones and your own head. And in order to give you feedback how you actually sound, this tool will give you kind of an icon to show you in a color code. Lisa. Good.
Support. My name is Florian. How can I help you today?
You see, I just got a 6.3 score with this one. Hello, welcome to audEERING Customer Support. My name is Florian. How may I help you today? So this brings me a 9, which is much better.
What the hell do you want? We're calling today to ensure you're getting the best value and service. BT have got enough of doing fucking phone call up your pissing ass and get me off this. This is an ex-directly phone and uncle fucking British Telecom. We pay the fucking bills now. Get the fuck off my phone line. Do you understand? I understand, sir. Good. Well, make sure it's fucking down or they don't let me again. Otherwise, I'll come and swing your screwy fucking neck and have him physically. No problem. You comprehend? Yeah, all it takes is a couple of seconds. Oh, God, you just know and fuck off. No problem. You comprehend? Yep, no problem.
So you saw the score drop down to 3.5 and it went all orange. So the agent also gets a feedback of how actually the customer is in its tone. And then they also get an implicit reward when they kind of convert a very angry customer initially and calm them down to a more happy one. All right. Next slide is one of the use cases, and I saw in the questions that there was also the use case suggested for autism therapy. And actually, we did that. We worked in a German research project where the goal was to build a robot that teaches autistic children social and empathic competencies. And you can imagine it very simplified in a way that they learn emotion expressions in voice and in face like a vocabulary. So they just learn what a happy expression is and practice that with the tool. And that was very well received by the children because they love more like techie gadgets and analytical ways of learning things. So very, very successful use case, and we're working with the partners to bring this further. Then another one from the healthcare space here, as we talked about vocal biomarkers before, is a study on multiple sclerosis. So we had a study with Inselspital in Bern, Switzerland, with 50 people who suffered from an early stage of MS. That's very important. So they barely had symptoms, and it was just that they were diagnosed barely. And we had 20 healthy controls. We found in the study that we could differentiate with around 70% accuracy whether an individual was from MS or from control group. And we also looked at some comorbidities that like depression or fatigue would co-occur with MS, or even fatigue is a very specific symptom of MS that occurs alongside it. And we looked at if we could detect depression or fatigue as it was given in questionnaires and assessments by physicians from the voice. We could do that here with 75%. So it's not anything that is 90 to 100%, and we can base a diagnosis on it, but it is something that is very useful in this complex diagnostic process because the diagnosis of MS is not straightforward. And the more markers we can explore to kind of fine-tune the therapeutic process, like what diagnostics to do next, when to do an MRI, how to interpret findings, the more we have, the better it is. And that really excited also the clinicians that we worked with, so that we're now continuing this research and going deeper here. All right. Then we have one last case before we actually near the end and open it back up for questions. With the US company Sales Boost, we developed voice analysis for them for coaching of salespeople. So practicing your everyday conversations you have. They start to do this in the hotel industry and the hospitality industry, practicing from scripts, but not only looking at what you say, but actually including your tone to sound empathetic, to sound friendly, and adapt this to the right situation. All right. And with that said, we have created one more example of our empathic dialogue. We used it to practice presentation coaching. Here we go.
Hello, I'm here.
Hello,
I want to practice my presentation and I want to come across well in my voice.
Sure, I'd be happy to help you with that. Let's get started on your presentation practice.
Can I just say one sentence and you comment on how I will be perceived by my audience?
Of course. I'm here to help. Go ahead and say your sentence.
Hello, today I will present you a product.
Your tone is calm and confident, which is great. But a bit more enthusiasm could make your introduction more engaging.
Hello, today I will present you a product.
Now that's more like it. You sound quite enthusiastic, which will definitely grab the audience's attention. Keep it up.
Hello, today I will present you a product.
This time you sound a bit down and less energetic. Try to maintain a positive and enthusiastic tone to keep your audience interested.
The product is something that I have just invented.
Your voice indicates less enthusiasm. Try to sound more excited about your invention. It will make your audience more interested.
The product is something that I have just invented.
Great! You sound enthusiastic and positive about your invention. This will definitely engage your audience.
All right, so that's a totally interactive way of practicing your presentation, not just giving it and receiving a screen and some feedback, but it's totally interactive. Now on the next slide, we just want to give you a very quick overview. What can you do if you want to work with this technology? As I mentioned before, you can go to our website, audEERING.com. You can go to products device, where you can instantly also purchase the prepaid packages for our web API. And then you can start, you will get the documentation, you get your access credentials, and you can get your own expression analysis done and integrated in your applications. We're also here to support you. So go to the contact form on the website or reach out through email to us. It's in the chat. And then you can reach out and get connected to us in order to use our products.
All right. Anything else, Florian? Sorry.
No, I'm done.
All right.
I think Soroosh has no video, but let's I think just use the time because we saw it before. So let's open it up to Q&A, right?
Yeah, I think we've got just one more. I know we're past. We'll just spend another minute or two. So we had a question from Anonymous. Where are your voices from? Are they hiring voice actors to record these prompts?
Right. So we're doing all sorts of ways of data collection. So we've worked with voice actors, but we're mainly working with non-professionals. So with people like you and me, we're trying to get speech where it happens naturally, where expressions are happening naturally. Using conversations, setting up conversations between people, or taking data that is publicly available that we can leverage. So there are multiple ways, and also acquiring data, of course.
There's actually an interesting question. I know this has been a pretty hot topic in the media. What is audEERING's response to those who say anthropomorphizing AI is dangerous and unethical even? What's your stance on it?
Well, of course. I mean, if we look at what actually we're doing now with deep fakes, where we can completely fake some identity, there are dangers with AI. And I mean, if we really make AI completely like a human, so if we put it in a human body and we try to connect with it, have feelings and everything, and not label it as an AI, that's potentially dangerous. And I don't think that we might want to have it that way. But if we look at the use cases we've shown, so if you imagine a robot that's clearly visible as a robot, not totally human-like, or any smart speaker or voice assistant that you have from your car to your home through your smartwatch or whatever, if that is a bit more empathetic and actually can detect that you're just being totally sarcastic if you say, oh, sure, that was so great. I think that would help our efficiency. It would help our experience, increase our efficiency when we use and interact with such systems without actually anthropomorphizing completely any AI.
Great. Thank you, Florian. I will take one final question. Can you share use cases for autistic students? I think you had shared one with the client, right? Any others? Did you text?
Not any that we can share at this point, but I think the main essence is the technology is perfect for teaching and coaching autistic children or people in general about their expressions. And of course, you can also imagine to put it on a device, like some augmented reality devices or anything that would help autistic people to actually see the emotions of somebody else. I mean, look at the Sheldon case we had in the first video. That's, I think, one of the examples.
For sure. Well, thank you, Florian. Thank you, Soroosh. I know you guys are on a mission to get Sheldon's dream to be a reality, but great job. I think this is tremendous progress we've made, right? Showing the historical track where we've been. Thank you again. Thank you for the Modev team for organizing this. Hope everybody has a safe rest of your day and evening.